Okay, hi everyone, welcome back to this video series on data centers configuring VTP. All Cisco iOS switches are configured to be VTP servers by default, so it's easy to assume that this is consistent throughout the NX OS, but it's not. Whether this is true or not depends upon the specific NX OS version you're dealing with. Some NX OS versions are set up as VTP servers by default, but some versions default to transparent. Okay, now to configure VTP, you've got to enable the VTP feature on the NX OS first. And of course, once you configure the VTP information on a switch, you need to verify it. When you configure VTP, you have a few options, including setting the domain name, password, operating mode, and pruning capabilities of the switch. I'm going to use the VTP global configuration mode command to configure all these settings. In the following example, I've set the S1 switch to VTP server and the VPT domain to LAML and the VTP password to Todd. Nexus 7K config feature VTP, Nexus 7K config VTP mode server, Nexus 7K VTP domain LAML, Nexus 7K VTP password Todd, Nexus 7K config VTP version 2, Nexus 7K VTP pruning switched on, Nexus 7K config SHVTP password, VTP password Todd, Nexus 7K config SHVTP status, VTP status information, VTP version 2 capable configuration, revision 0, maximum VLANs supported locally 1005, number of existing VLANs 5, VTP operating mode server, VTP domain name LAML, VTP pruning mode enabled, operationally enabled, VTP V2 mode disabled, VTP traps generation disabled, message digest 0x02, 0x11, 0x18, 0x4b, 0x36, 0xc 5, 0xf4, 0x1f. Configuration last modified by 0000 at 00000000. Local update ID is 0.0.0.0, VTP version running 2. Please make sure that if you want to change and distribute any VLAN information on a switch, you absolutely must be in a VTP server mode. In the preceding example, I had used just about every VTP command there is. There are a lot of commands to configure VTP and not only one to verify it, which can make it tough for troubleshooting. VTP pruning is helpful in stopping a VLAN broadcast from traversing a trunked link if there are no ports in the VLAN on the receiving switch. However, not all switches support VTP pruning. After you configure the VTP information, you can verify it with the show VTP status command as shown in the preceding output. The preceding switch output shows the VTP domain, the VTP mode, and the switch's VTP password. Let's go to the Nexus 7K and 5K switches that I connected together and set them into the LAML VTP domain. It is very important to remember that the VTP domain name is case sensitive. VTP is not forgiving. One small mistake and it just won't work. Let's take a look. Nexus 7K SHVTP stat VTP version 2 capable, configuration revision 4, maximum VLANs supported locally 1005, number of existing VLANs 8, VTP operating mode server, VTP domain name LAML, VTP pruning mode enabled, operationally enabled, VTP V2 mode disabled, VTP traps generation disabled, MD5 digest 0x0f 0xC9 0x98 0xAC 0x87 0xF7 0x1E 0x74 configuration last modified by 0.0.0.0 at 5:15:11 00:03:29 local updater ID is 0.0.0.0 VTP version running 2 Nexus 5K show VTP status VTP version 2 configuration revision 4 maximum VLAN supported locally 1005 number of existing VLANs 8 VTP operating mode client VTP domain name LAML VTP pruning mode disabled VTP V2 mode disabled VTP traps generation disabled message 5 digest 0x0f 0xC9 0x98 0xAC 0x87 0xF7 0x1E 0x74 configuration last modified by 0.0.0.0 at 0.00:00:00. First, I want you to notice that there are 2 switches and that each is running VTP version 2. The next line is one of the most important lines because it reveals the VTP database revision number. The server's database number must be higher than a client's or regular servers in order for the database device to even receive and process the database, because if the number is the same or lower, the switches will just discard the summary advertisement as though it was nothing. Okay, next up we see the number of existing VLANs, a total of 8, including 5 default VLANs, VLAN 1 and 00 through and 1002 through 1005. So we clearly have 3 configured VLANs. Moving on, we see that our VTP mode is client, but it could show up as a server, client or transparent or even off. The domain name LAML is very important as well, and it absolutely must be the same in all switches. In case you're wondering, the answer is yes, it's case sensitive. The last 2 lines present the MD5 digest used for the VTP password and the IP address, if shown, of the specific server that we received the VLAN database from. Did you notice that the MD5 hashes match exactly on both switches? This means our VTP passwords match on both of them. By the way, this just happens to be a great troubleshooting tool, because if your domain name and passwords don't match, VTP summary advertisements will be rejected. So don't forget to don't forget to run the show VTP password command on both switches to verify that the MD5 matches. Let's mix things up now by connecting a router into our switched network and configuring Inter-VLAN communication. Configuring Inter-VLAN routing. Hosts in a VLAN live in their own broadcast domain and can communicate freely. VLANs create network partitioning and traffic separation at layer 2 of the OSI, and as I said when I told you why we still need routers, if you want hosts or any other IP addressable device to communicate between VLANs. You just have to have a layer 3 device to provide routing, period. For this, you can use a router that has an interface for each VLAN and a router that supports 802.1q routing as shown in figure 1111. If you have only 2 or 3 VLANs, you can get by with a router equipped with 2 or 3 fast Ethernet connections, and unless you're someone housing a huge multi-department staff, 10 base T is perfectly okay for home use, but only for home use, because for anything else you need serious power, and I'd recommend fast Ethernet or gigabit interfaces for that. In figure 1111 you can see that each router interface is plugged into an access link. This means that each router's interface IP address will become the default gateway address for each host in each respective VLAN. If you have more VLANs available than router interfaces, you'll need to either configure trunking on one fast Ethernet interface or buy a layer 3 device such as a Nexus switch R. But if you go with the latter option, do remember that not all Nexus switches support layer 3 routing. Choose carefully. If you're short on cash, you can use one fast Ethernet interface and run 802.1q trunking instead of using a router interface for each VLAN. Figure 1111 shows how a fast Ethernet interface on a router will work when configured with 802.1q trunking. Doing this allows all VLANs to communicate through one interface. Cisco calls this router on a stick. I've got to say that really nailed this well. You much better off using a higher end switch and routing on the back plane when you're dealing with a large or enterprise network. Deploying Inter-VLAN routing IVR onto the switch fabric is the way to go, because it's a lot faster for basic VLAN connectivity. This is known as a switched virtual interface SVI, and it's logically configured on the switch, but it's rare to be able to replace your external routers in all circumstances, because every network is different with different needs, so design each accordingly. Differences aside, let's take a look at a typical VLAN network now and then configure NX-OS with SVIs to provide layer 3 routing between VLANs. Figure 1113 shows a Nexus with 3 VLANs configured. As you know, the host in these VLANs can't communicate to hosts outside their own VLAN by default. I just addressed this issue by connecting a router port into each VLAN and then configuring router on a stick. Let's go inside the Nexus 7000 workhorse and configure SVIs for each VLAN to enable inter-VLAN routing. Nexus 7K config feature interface VLAN Nexus 7K config interface VLAN 10 Nexus 7K IP address 172.16.10.1/24 Nexus 7K config if int VLAN 20 Nexus 7K config if IP address 172.16.20.1/24 Nexus 7K config if int VLAN 30 Nexus 7K config if IP address 172.16.30.1/24. And you thought this would be hard right first? I enabled the SVI feature and then the interface for each VLAN, followed by the IP address that will become the default gateway address for each VLAN. Each VLAN's host can now communicate with others through the switch fabric. One last thing, it's really important that you don't get the commands VLAN 10 and interface VLAN 10 confused. Instead, remember that the first generates the VLAN in the active configuration file, and the second configures the router interface for that specific VLAN. Summary. This chapter introduced you to the world of virtual VLANs and described how Cisco switches can use them. You saw how VLANs break up broadcast domains in a switched internetwork, a very important necessary thing because layer 2 switches only break up collision domains, and by default all switches make up one large broadcast domain. I also described access links to you, and we went over how trunked VLANs work across a fast Ethernet or faster link. You know that you really shouldn't ever change, delete or rename VLAN 1 because it's the default native VLAN. This means that any layer 2 ports that aren't specifically assigned to a different VLAN will be sent down to the native VLAN, VLAN 1. You would want to mess with this arrangement only to meet some pretty unusual security requirements. Trunking is a crucial technology to understand well when you're dealing with a network populated by multiple switches that are running several VLANs. I also talked at length about VLAN trunking protocol, VTP, which in reality has nothing to do with trunking. You learned that it does send VLAN information down a trunked link, but that the trunk configuration in and of itself isn't part of VTP. This chapter also provided important troubleshooting and configuration examples of VTP trunking and VLAN configurations, including Inter-VLAN routing. So I'm going to leave it here today for this video. If you like listening, please consider like, sharing and subscribing. Thank you.